Hi there, I just want to do a couple of homework problems for you. So this one is for what value of the constant c is the function f continuous on negative infinity to infinity? This is problem number 45. So we're trying to choose a value of c which makes this function continuous everywhere. I first want you to notice that if you look at the individual pieces of this function, which would be this red part for less than 2 and this blue part for greater than or equal to 2, those individual pieces are just polynomials, so those are going to be continuous everywhere in their domains. The only issue happens at x is equal to 2, so that's where we have to choose a value of c which makes the two pieces of the function connect, and so then it will be continuous. So this is how I would write this. I would say that number 1, I want f of 2. I have to make sure f of 2 exists for a function to be continuous at 2. F of 2 in this case, I'm going to use the blue rule, and I would get 8 minus 2c. Okay, the next thing I need to do is look at the limit as I approach 2. Now, it's a piecewise function, and we've got different rules on both sides of 2, so we are going to need to use one-sided limits. We're going to check out the one-sided limit coming in from the right, so that's going to be our greater than, so the blue rule, and I would just put 2 into my blue rule to get out 8 minus 2c. So from the right, it's the same as the function value, actually. This is 8 minus 2c. If I come in from the left, right, now I have to use my red, oops, wrong color there. I have to use my red rule. That would be c times x squared plus 2 times x. So this will be c times 4 plus 2 times 2, that's 4c plus 4, right? So coming in from the left, it's 4c plus 4. So for this limit to exist overall, those one-sided limits have to be equal, right? So I'm going to set the left one equal to the right one and see what that gives me for c. So I go 8 minus 2c equals 4c plus 4. That means negative 6c is equal to negative 4, or c is equal to negative 4 over negative 6, which is 2 over 3. So if I choose c equal to 2/3, then the limit exists at 2, the overall limit, and it would be equal to, well, it could be 8 minus 2c, which is 8 minus 2 times 2/3, that's 20/3. But let's just make sure that the other one, 4c plus 4, the limit from the left, what would that be? Well, 4 times 2/3 plus 4, that's also 20/3. That's exactly what we wanted, right? From the right or from the left, I'm getting the same number. So the overall limit is 20/3 if I choose c equals 2/3. Now, the third condition for continuity is that f of 2 has to be equal to the limit. Well, let's check f of 2. F of 2 is 8 minus 2c, so if c equals 2/3, f of c will be 8 minus 2 times 2/3. That is also 20/3. So if I choose c equals 2/3, the limit of f as x approaches 2 is equal to f of 2. All of this is equal to 20/3, and we're good to go. So function is continuous at x equals 2. Okay, so for this problem 46, we do exactly the same thing, except we look at the 2 points x equals 2 and x equals 3, because there are 3 rules and 2 boundaries in this piecewise function. So for x is equal to 2, the function value at 2 is simply equal to 4a minus 2b plus 3. Then we look at the limits coming in from both sides of 2. Coming in from the less than side, we get 4. And coming in from the greater than side, we're going to plug it into ax squared minus bx plus 3, and we get 4a minus 2b plus 3. So we want the overall limit at 2 to exist, and that will only happen if 4a minus 2b plus 3 is equal to 4. If that happens, the overall limit at 2 will exist, and notice that's also the same equation as f of 2, so that will also exist and the 2 will be equal. So this is one equation. We can simplify it into 4a minus 2b is equal to 1. That's going to be one equation. Then we look at x is equal to 3, do the exact same thing there. The function value at 3 is equal to 6 minus a plus b. The limit as we come into 3 from the less than side is equal to 9a minus b plus 3. The limit as we come in from the right side is equal to 6 minus a plus b, which notice is the same as the function value. So we want to set these two things equal. 9a minus b plus 3 has to be equal to 6 minus a plus b, because if it is, the overall limit will exist and it will be the same as the function value. So this becomes 10a minus 2b is equal to 3, and that's my second equation. And so we now have two equations in two unknowns, and we can solve them both, and I believe your answer comes out to be a is equal to 1/2 and b is equal to 1/2.